Everybody, I'm Yogesh, a PhD student at IIT Bombay, India. In this in vitro study, we will investigate how quadriceps forces affect static versus dynamic trials under identical loading conditions. So, knee simulator mimic knee motion on a cadavers. There are two types of knee simulator: static simulator, which apply passive quadriceps on quadriceps load with no knee motion, and the dynamic knee simulator, which uses active quadriceps load with knee motion. Both quantify pre and post operative knee biomechanics, but surgeons still use a static knee simulator even if they lack physiological realism. So the question is, are the quadriceps forces are really the same to quant? So our aim is to quantify quadriceps forces in both of these conditions. So this is our knee simulator, as you can see in the figure. In this, our ankle go up and down to do something like a squatting activity. Coming to the other parts, we are using 3D printed knee, phantom knee, and we are using a linear actuator to replicate muscle forces. We are using encoders to measure friction angle and load cells to measure ground reaction forces and muscle forces. Three conditions were tested on the same specimen. The first condition is the dynamic squat, where we will move the knee from 20 degree to 100 degree in a cyclic manner as using this position fit point control, as you can see from the picture. Also, we are using parallelly a ground reaction forces controller, where we will maintain a constant ground reaction forces by applying quadriceps actuators. The second condition is the condition where incremental squats, where we go from 20 degree to a steady state value x degree, and in the second condition it's a static squat, where we will hold the simulator at a particular angle and we apply a quadriceps forces to get to a particular region, to get to a particular ground direction forces. Then coming in, so these are the results of the quadriceps forces. As you can see, the quadriceps forces vary quite differently with the phases. So the first, so as you can see that the static and incremental is higher in descent phases, where in dynamic is very higher in ascent phases. So why does this happen? So if you are curious about how motions affect the quadriceps forces, please do visit my poster on 8th of July. Thank you.